All right. This example, again, is converting sample data in the data scale into a z-score scale. This is relating to exam scores. So you could think of percentages as a unit of measure. The sample mean is 77.3%, and the sample standard deviation is 13.4%. Convert the exam scores on a percentage scale to a z-score scale. Make a dot plot and complete the frequency table below. So, we're going to take values of x, and values of x are the datums in our random variable. Our random variable is exam score. So each of these dots represents a datum in that data set. So in order to convert these values of x into a z-score, then we're going to need the sample mean and the sample standard deviation. Now, for the purposes of this example, you were told what the sample mean and the sample standard deviation are, but you could have just put these values into your calculator and calculated the same thing. Now, what I'm showing here down below is just to kind of show you a little bit more about how the equation works, and how you would do it manually. So what you need to do is, kind of in turn, you want to take one of the unique datums in our exam score percent here. So one would be 64. So you let x equal 64, and you put 64 in place of x. And the sample mean, we were told, is 77.3, and the sample standard deviation is 13.4. So we just put 77.3 in place of x bar, and then we put 13.4 in place of s. And when you simplify this expression on the right-hand side, then when x is equal to 64, you get a z-score of negative 0.99. So down here, if we put 64 in for x, we get a z-score of negative 0.99. So 64 in a percentage scale gets converted to negative 0.99 on a z-scale. So let's go ahead and maybe plot that. All right, so we've got two values on a z-score of negative 0.99. That's almost negative 1. So I'm going to plot it right here. So here's 1 point, and here's our second point. All right, got that one done. Now 68. So now we want to take our x value of 68. We've got two of those. So when x is equal to 68, what's our z-score? So we substitute 68 in for x. We have the same mean, sample mean, and sample standard deviation. And that'll come out to a z-score of negative 0.69. So here, when we have 68%, that translates to negative 0.69. So negative 0.69, so this is approximately negative 0.5. This one is negative 0.75, so 69 would be somewhere right about here. Okay, we got two of those. Again, this is just a sketch, so it doesn't have to be perfect. All right. Now 70. So 70 is right here. We've only got one of those. So when x is equal to 70, then we're going to put 70 in place of x. And then this is x bar and this is s. Simplify that. So when x is 70, z is negative 0.62. Okay, so when x is 70, z is negative 0.62, which will be just below that one. And there's only one of those. All right. And let's see, for 85, okay, right here, then when x is 85, we can put 85 in for x, same x bar, same s, and we get a z-score of positive 0.57. So positive 0.57 when x is equal to 85. 0.57 would be somewhere right about here. And we've got two of those. All right, so notice that the z-scores that we just calculated previously, okay, those were all negative. And this is the first one that's positive, right? Why is that the case? Well, if we look up here, right, our sample mean was 77.3. So we're 77.3. So 77.3, so 76, 78, 77.3 would maybe be somewhere right about here. Right? And so where the center is, where the mean is on this exam score percent scale is where 0 is going to be on our z-scale. Okay. And so what do you notice? If we come up here, we had these 5 points to the left of our mean, and we've got these 5 points to the left of 0. All right, see how that works? And we just calculated the first unique datum to the right or above the sample mean. So that was the reason why this value came out to be a positive 0.57, because these are the points that are to the right of the sample mean. And on a z-scale, to the right of the center is going to be to the right of 0, which will be a positive value. Okay. So that's why this value suddenly became positive. And if we do the same thing here with 92, here's 92. We only got one of those. And so when x is equal to 92, put 92 in for x. Sample mean, standard deviation is the same. Comes out to a positive 1.10. Okay, so that's a little bit more than positive 1. So that would be right about here. And there's only one of those, right? There's only one. All right, got that one done. Okay, last one. Okay, that's when x is 100. So if x is 100, we put 100 in for x. We have the same sample mean, the same standard deviation. The right-hand side will simplify down to a positive 1.69. And so when x is 100, then the z-score will be positive 1.69, which will be maybe somewhere right about here. Again, this is a sketch, so just close enough. All right. Now, if we've done things correctly, then the shape of the data that we have up here should be the same as the shape of the data that we have down here. So converting values from, any unit to a unitless z-score isn't going to change the shape of the distribution. And in fact, they're going to have the same relative distances from each other. Um, and of course, I think the important thing to kind of highlight here was this split, where you had negative z-scores and positive z-scores, and that split occurred because the sample mean was 77.3, and 77.3 is right here between 70 on that side and 85 on that side. So it makes sense that these would be positive z-scores on this side and negative z-scores on this side, with a mean of 77.3 being equal to a z-score of 0, right there in the middle. Okay, so that's it for that example. Let me know if you have any questions.